Good morning, everyone. Welcome to my concept video. Before entering to video, let me introduce myself. Myself, Bhuvneshwar, studying computer science and engineering from Institute of Aeronautical Engineering. If you want, my roll number is 21951A0527, and today in this whole concept video is about topic star delta transformation. The whole ppt is around the top. My topic is star delta transformation. Without any further delay, let us move into the topic and contents. In the whole video we are going to discuss what is star network connection, what is delta network connection, star delta transformation, and some examples and problems on star delta transformation. These are the whole topics I am going to cover this in this whole concept video, which is these are the major topics I am going to cover. What is star network connection, what is delta network connection, what is delta transformation, some examples and problems on star delta transformation. Now, without any delay, we will move into the further slides. See, these are some pre-requirements of the video to know, which we should know to know about star delta transformation. Let us quickly say what are this in just in conclude you in 5 minutes. The term, if what is a star connection? Basically, the terminals of the three branches are connected to a common point. The network formed is known as star connection. The starting and the finishing point, that is similar ends of the three coils, are connected together. Neutral or the star point exists in the star connection. Line current is equal to the phase current. Line voltage is equal to the root 3 times of the phase voltage. See, basically the star connection is nothing but, if we see, if three terminals are branched for one node or with a common point, then it is called an star connection. Let me show. I will show you a diagram later. For as of now, remember the point that star connection is the terminals of the three branches are connected to a common point, and the network formed will, if the after connecting a common point, the network formed is known will be an star connection. And these are the related points which are related to star points which I had right now. There will be further points I will. The speed of the star connected motor is low as the receive 1 by root 3 of voltage. Requires less number of, for star connection it requires less number of turns. Insulation is required low for the star connection, mainly used in power transmission networks. See, the star network connection is mostly used in power transmission networks. In star connections, each winding receives 230 volts. Both the 3-phase 4-wire and 3-phase T3-wire system can be derived in the star connection. See, this is the diagram for the star connection. Let us take R raised to Y, B, which are connected to a common point. This is taken node, which are this is called star connection. All the three are connected to a one point. This is the star connection. Now let us see what is the delta. See, before entering into this, it is also known as, see, star is also known as T. Suppose if you stretch it, this resistor this like, and this resistor, then it's almost looks like a T, right? See, before it looked like an star or like Y, but we can restructure it into the T. So this is also known as T connected network. See, it is also known as T connected network due to the shape after rearranging the network branches. I think so you got my point. Now let us see that what is meaning delta connections. The three branches of network are connected in such a way that it forms a closed loop known as delta connection. The end of each coil is connected to the starting point of other coil. That means the opposite terminals of coils are connected together. Neutral point does not exist in the star connection. Line current is equal to root 3 times of the phase. See, the basic idea of delta connection is there won't be any common point. All are connected in a triangle like structure. There won't be any neutral point or so common point, so called. Like star, they won't exist any neutral point in delta connection. And next points, the speed of the delta connected motor is high because each phase gets total of line voltage. Phase voltage is equal to the line voltage. Requires large number of turns. High insulation is required for the delta. Used in power distribution. You see the in star it is used for power transformation, but the delta transformation is mostly used in power distribution. In delta connections, each winding receives 414 volts. Three-phase 4-wire keystone can be derived from the delta connection. Now let us see the diagram of how really the delta networks look like. Let us take this in blue, red, and white. White will has the name indicates the color. If these are connected in such a way such shown in the diagram, without any common point, all one point will be merges with another and form a triangle, then it will be a delta connection. They won't see here there is no point that three wires are made, but before in star connection we can see that there is a common point that this resistor and this resistor and this resistor, it won't be any resistor. We can take an inductor also. If the common point, if we arrange, it will be a star connection. But while coming to the delta connection, there won't be any point where the three resistors meets. This is the delta network. As we call star connection as a T connection, the delta networks can also be called as pi C, because after rearranging this C, making this as grounded like this, we can just adjust. If you stretch this like into, if you stretch this one, it almost looks like this. There won't be any, as this voltage here is will be the same, so there won't be any changes. So it can also be called, which looks like the pi C. The symbol is almost like pi symbol, right? Pi with the mathematical pi. So it is also known as pi network because it resembles the letter after rearranging, it's almost look like a letter pi, so we can also call it a pi network. See, now let us what is star conversion. See, if a given network is in like in a star, if you want to convert it into the delta to find out the values easily, then we use star delta conversion. Suppose let us take an star connection with R1 between AB, R2 between BC, and R3 between AC, and if you similarly transfer, then there will be between A and the common point there will be RA, and a common point between C there will be RC, and AB RB. Now by using these values we will find out RA, what will be the value of RA, what will be the RA of RB, and what will be the R of SC. If you place the similar network, if I transport this to here and this to here, we can convert the values easily. Let us see the derivation how to convert the star network into the delta network. The given figure before the given figure shows a delta network having ABC terminals with impedance. Okay, it won't, you can consider impedance or resistance, there won't be any problem, we can consider anything. As of now, let us think it is an impedance, will be R1, R2, R3. The equivalent star connected network with RA, RB, RC, where they are connected to their corresponding terminals as shown in the figure, as shown in this A, B, C, R1, R2, R3, and RA, RBC, RBC are connected in this star and the delta. As mentioned earlier, the terminals ABC remains the same, as well as the impedance between them must remains the same. Now let us try to make equations. The total impedance between AB in the delta network RAB is equal to R1 C in C here. In delta network, the total impedance between R and A, this is in delta network between RAB total impedance will be, as this is in parallel with these two are in series parallel with this one, we can R1 is parallel with series R2 and R3. So by using this RA RB is equal to R1 is parallel to in series with R2 and R3, RAB is equal to, as we know, the when resistors or impedance are connected in parallel, it will reciprocal of 1 by R1 plus 1 by R2. So by using this we can get the equation RAB equal to R1 into R2 plus R3 divided by R1 plus R2 plus R3. Similarly, the independence between terminals similar is applying the same concept of how we find out the overall between the AB. Applying the same concept between AC, we can get RBC equal to, where RBC is parallel between R3 of R1 plus R2. So RBC will be R3 into R1 plus R2 divided by R1 plus R2 plus R3. Similarly, the total impedance or reactance between the AC will be applying the same concept. RAC is parallel to RAC is equal to R2 parallel to R1 plus R2. Therefore, RAC is equal to R2 into R1 plus R2, RA plus RB plus RC. As see, let us name this first text as equation 1. This is equation 2. This is equation 3. We got the three equation for RA, RAB, RBC, RAC for delta network. Now according to as we got RAB, RBC for delta network, let us try to figure out the same values for star. For what will be for AB, just add this two. There won't be any effect of this C. If you want RAB, just add RA plus RB. In the similar way, if you want between BC, just add B plus C. If you want for AC, just add RA plus RC. In this way we can get that, derive that RAB is equal to RA plus RB, RBC is equal to RB plus RC, RAC is equal to RA plus RC. Don't these are simple equation. I am not mentioning with any equation names. Just remember RA will be equal to RA plus RB, and RBC is equal to RB plus RC, and RAC is equal to RA plus RC. Now adding equation 1, 2, 3 together, which see this equations which we got earlier, RAB, RBC, RBC, by adding these three equations, RA plus RA plus RB plus RC, we will get that R1 into R2 plus R3 divided by R1 plus R2 plus R3 plus R3 into R1 plus R2 divided by R1 plus R2 plus R3 plus R2 into R1 plus R3 divided by R1 plus R2 plus R3. By replacing from this star network, RAB is equal to RA plus RB, RB is equal to RB plus RC, RAC is equal to RA plus RC. Replacing with this, we get 2RA plus 2RB plus 2RC is equal to, by solving this from this we get R1 plus R2 plus R1 plus R3 plus R1 plus R3 plus R2 R3 plus R1 R2 plus R2 R3 divided by R1 R2 R1 plus R2 plus R3. 2RA, finally we will get the equation 2RA plus 2RB plus 2RC is equal to 2 of R1 R2 plus 2 of R2 R3 plus 2 of R1 R3 by R1 plus R2 plus R3. Taking 2 out common from this and this, just cancel out the 2 and 2, we will get the final equation. Let's mark equation number 4 as RA plus RB plus RC is equal to R1 R2 plus R2 R3 plus R1 R3 by R1 plus R2 plus R3. Now subtract equation 1, 2, 3 from 4 to get RA, RB, RC in terms of R1, R2 and R3. See, from RA plus RB plus RC with equation 4, subtract equation 1 and 2. Now here I am subtracting equation 2. Now I will get RA. Here I am getting RA in terms of R1 and R2 and R3, as RA is equal to R1 plus R1 R2 plus R2 R3 plus R1 R3 minus R1 R3 minus R2 R2 by R1 plus R2 R plus R2. RA will be R1 R2 divided by R1 plus R2 plus R3. Now subtracting equation 4, 6 with similarly sorry, See, now doing the same, we are subtracting 1 and 2. Similarly, we will get R as R1 R2 by R1 plus R2, and RB as R1 plus R3 by R1 plus R2 R3, and RC as R2 R3 divided by R1 plus R2. Now we got delta to star equation. See, I am getting RA in terms of R1s and R2s and R3s, RB in terms of R1s and R2s. See, similarly RC, this we got delta network into star, but what we require is star into delta. By using this three equation, we will try to get the star network in terms of delta network. In order to find the equivalent delta resistance, multiply the previous equation as I marked here. So 5, 6, 7, as we got from the delta to star, mark these equations as 5, 6, 7. By using this in order to find equivalent delta network, multiply the previous equation 5, 6 as well as with together, multiply 5 and 6. RAP is equal to R1 R2 divided by R1 plus R2 plus R3 into R1 R2 by R1 plus R2 plus, then we will get RA RB is equal to R1 square R2 R3 divided by R1 plus R2 plus R3 whole square. Simply multiplying 6, 7, 8 with the 6. Similarly, how we did here, similarly doing the same thing, we get RB RC is equal to R1 R2 R3 square by R1 plus R2 plus R3 whole square, and RA RC as R1 into R2 square plus R3 3 divided by R1 plus R2 plus R3 whole square. Okay, now to get in star into network, now add the equations 6, 7, 8 together. Here as I mentioned, this will be let us consider this is equation 8, this is equation 8, this is equation 10. Now by adding these three equations, RA RB plus RB RC plus RA RC equal to R1 square R2 R3 divided by R1 plus R2 plus R3. Similarly, R1 R2 R3 square divided by R1 plus R2 plus R3 whole square, R1 into R2 whole square, R3 by divided by R1 plus R2 whole square. Now adding these three, we will calculating, it will become RA RB plus RB RC plus RA RC is equal to R1 square R2 R3 plus R1 R2 R3 square plus R1 R2 square R3 divided by R1 plus R2 plus R3 whole square. RA RB plus RB RC plus RA RC equal to R1, taking R1 R2 R3 common, R1 R2 R3 into R1 plus R2 the whole square. By cancelling this and this, we will get RA plus RB plus RB RC plus RA RC equal to R1 R2 R3 divided by R1 plus R2 plus R3. Let us mark this equation 9. In order to get the individual equivalent delta impedance or resistance, we divide equation 9, 5, 6 and 7 separately, such that dividing equation 9 with 5, which we divide here equation 9 with equation 5, we will get corresponding RA, R1, R2, R3 in terms of RA, RB, RC. See, but if you get RA, RB, R1, R2, R3 in terms of RA, RB, RC, which is nothing but we are deriving star values in terms of delta values, as we got RA is equal to RA plus RB plus RA plus RA RB plus RB RC plus RA RC by RA, R2 is equal to RA RB plus RB RC plus RA RC by RB, R1 equal to RBRC plus RARB. These are the three equations which are which converts into star values into the delta values. Otherwise, this table clearly defines difference between, while converting from star to delta, we will get RA is equal to R1 R2 divided by R1 plus R2 plus R3, RB equal to R1 R3 by R1. This is star and this is delta. This whole table clearly defines the major difference between converting delta into star and star into delta. These are the formulas while we are converting delta into star. These are the formulas while we are converting star into the delta. See, suppose in case all impedance or resistance are equal, the equivalent delta impedance would be, using the previous equations, we get R of star is equal to R of delta by 3, or R delta is equal to R 3 into R star, which means if you want to convert star into delta, just divide the, if all impedance are equal, just divide the delta equal in divide by 3 and you will get the R star. If you want in similar, if you want R delta in terms of R star, just multiply by 3, you will get the values. Thank you. And finally I am concluding the video that in this whole concept video I discussed each and every point about the star delta transfer from the basics, and at last I gave the equations even from delta to star and star to delta. These are the equations, and even I covered the concept of called what if all impedances are equal and what happens to star and delta, how are they get divided, and this is my whole concept video. Thank you.